Good evening, everyone. I hope I'm audible to all of you. Please confirm on the chat if I'm audible. Okay. So, I welcome you all to our fifth day of our training machine learning using Python. So, meanwhile, everyone is joining. We'll start in just 2 3 minutes. So, we'll wait for the other participants to join for 2 3 minutes. Right now, very less number of participants are there, so we'll wait for some time. Meanwhile, what you can do is you can open the last file, last day collab file, and run all the code from the beginning by uploading the data set. First of all, upload the data set and run each and every code in the meanwhile. Okay, and then we'll start. So simply, if you can see my screen, I have simply opened the last day file, the last day collab file on which we have worked. I told you yesterday that we'll continue the same file today. Okay. Yeah, yeah. Good evening, Iruko. Good evening, Alok. Yesterday, I told you to copy the path. After uploading the file, simply right click on the file here and copy path. That's all. Okay. Meanwhile, if you have any questions, you can ask me till the other participants are joining. Tell your friends and colleagues to join those who have not joined. Tell your friends and colleagues so that they don't miss anything. Okay. So let's start now. So once again, good evening to everyone. So in the last class, we have discussed about the pandas. Okay. We have learned how to use pandas library for the data manipulation. And we have done some manipulation things in our data, like whatever things we have done. First of all, we have imported the CSV file. After importing the CSV file, we have checked the information of that file, how many rows and columns are there, what is the data type of that columns, each and everything we have checked. Then we check the statistical information. We learned how to access column. We learned how to access rows using ilock and lock function, and then we learned how to handle missing values. So we have discussed 3 4 situations where we can use for the missing values, right? And then at the end we discussed about filling the missing values. So these are the things that we have discussed in our last session. Okay. Now today I'm going to continue from here. So what I'll do now, first of all, I will upload the CSV file in my Google Colab, the same CSV file which we have used yesterday. Okay. So I'll simply click on this upload button and upload the same file. Just give me a minute. Okay. So after uploading the file, the same file, you'll get your file here. And now you can run the complete code. You can go to runtime and click on run all. It will run the complete code. Okay. So it will take some time, 10 to 15 seconds. Okay. So now my complete code is executed. Okay. Now if I scroll at the bottom and in the chat, as a pinned message, I have given the link of my this collab file. Okay, you can take it from there. Okay. Now, if I print here data dot head, So this is my data which I got here right now. And in this case, I'm not having any missing values because I have simply ran the last code. Okay, so I'm not having any missing values in this data. You can check here, there is no missing values. Okay, now the first thing that I am going to discuss today is how to change the data type of any column. How to change the data type of any column. Now, if you see the data type of each column, now I would like to ask you all, tell me which data type you feel is not correct according to the data. Like first name is a string, so here we have a string. Object, you can consider it as a string. Okay, gender string, start date string, last login time string, salary integer, bonus float, this one object, this one object. So tell me which one you feel is not a correct data type. Tell me which one is not a correct data type. What do you feel here? Salary. What's the problem in salary? It's an integer. No problem. It's a numeric number, na? That's not a problem. Yes, date and time. These two columns should be date and time. It should be of the date time data type. Date time data type. That is the problem here. Okay. And senior management, what is the data in the senior management? If you see, the data in the senior management is true false. And what is that true false data called? What we call the true false data? Bonus is fine. Bonus is float. That is fine. Bonus is correct. Yes, Boolean. That means senior management should be Boolean. So let's convert these data type and let's understand how to change this. So first of all, I am doing it for the date. Now, just remember one thing. In the pandas, the data type for the date that we use is this one. Date, time, 64, and S. This is the data type that we use in pandas for the time and date functionality. For the time and date functionality. So this will be this we will be using to convert. So to convert this, what I'll write here, data of start date. First of all, I am doing it for date. So start date is equal to. Now, do you remember the function name which we have used in the NumPy array to convert the data type? Same function we have here also. What was the function name, if you remember? Anyone? In the NumPy array, which function we use to convert the data type? It starts from A. I'm giving you a hint. Yes, very good. It is age type. So it's good to know that you remember. Good. So here I'll write date, time, 64, and next. Now this is a predefined name. You cannot change it. That's a predefined name for the date time. It's a predefined. Okay. Similarly, if I want to change for this one, I'll take the same thing. Okay. And the last one will change it for the senior management also. Now for the senior management, I will convert this into Boolean. I'll convert this into Boolean. So I'll write here bool. Bool is for Boolean. Okay. So now if I run this, my data type is now converted. Now if I check the info, now look here, date time 64, and Boolean, and see the change in the memory. Here the memory usage was 62.6 kilobyte. And here you can see it has changed to 55.8. So 10% of the memory usage is reduced. So we reduce the memory usage also. Because date time and Boolean takes less memory as compared to the object data type. It consumes less memory. Okay, so this is how we convert the data type of any column using h type function. So just remember this. Okay, I hope this is clear, everyone. Okay, and today I'll answer all the doubts at the end. So whatever question you are having, just keep your questions note down in a notebook or something and ask me at the end. Okay. Okay, now the next thing here, I'll write in the comment here, change data type of column. Okay, now I'm going to tell you how to rename column. Let's say you want to rename the column, rename any column. Now you all tell me which column should I rename. You only tell me which column should we rename. Um, this let's let's change this to joining date. Is that fine? If I change this to joining date, start date, I'll change this to joining date. Or this bonus percent, I'll simply change it to bonus. I don't want this percent here. I'll simply change this to bonus, not percent. Okay. So I want to rename these two columns, this one and this one. These two I want to rename. So for that, how to do that? First of all, if I want to modify in my data, if I want to change in my data, I have to write here data equal to this. Okay. Then data dot rename. Data dot rename. Now in this rename, you have to pass what you want to rename. Either you want to rename this index, I can change this index also. Or I want to rename this column. Generally, we don't go for index because it's not required. So I'll write here that I want to rename columns. So I'll write here columns equal to, and then here you have to create a dictionary. I hope you all remember dictionary. This we have covered in the Python class. Okay. So in the dictionary, first of all, as a key, you have to pass the old name. The old name is start date. And then as a value, you have to pass the new name. So let's say the new name is joining date. Then comma. The next I want to change is wait. Next I want to change is bonus space percent, and I will change this to simple bonus. Now I'll run the code from the beginning because I have ran this code one time. So now already this column is changed. So it will give me the error. That's why I'm running it again from the beginning. Okay. So by giving comma, you can give multiple columns, name of the column that you want to change. Okay. So now it's changed. Now let's run this and check whether it has changed or not. So I'll write here data.head. So you can see that we renamed the column. Here now it is bonus and here now it is joining date. So this is how we rename the column. I hope it's clear, everyone. Yeah. Simple. So we learned two things: renaming the column, changing the data type of the column. Okay. Now the next thing that we are going to learn is how to drop. Drop means delete either rows or columns from data frame. Let's say you don't want any column. So there is one column which is useless. You don't want that. Okay. So how to drop that? How to delete that rows or columns? Let me tell you that thing now. So first of all, I am going to tell you about dropping off rows. Dropping off rows. How to drop any row. So tell me, what is the unique thing in each row? What is the unique thing? If I go to each rows, what is that unique thing that I can see in the row? Tell me. Index, correct. The unique is the index. So we have to use the index to delete the row. Okay, so I'll write here data dot drop, and I'm not modifying my original data, so I'll write here data underscore new equal to, because I don't want to make the change in my data variable. So I'm taking a new variable here, data underscore new. Okay, data dot drop, and here you will pass in the bracket whatever row number you want to pass. Let's say I want to delete row number 1 and row number 4. This two I want to delete. So I'll simply write here 1 comma 4. These two I want to delete. So I'll simply write here 1 comma 4. Then we have to include one argument, which is axis. This is very important. So if I want to delete row, I have to pass 0. So axis equal to 0 means row. That means I want to delete row. Now, if I run this and if I print this, you can see that 1 and 4 is gone. It's gone. It's deleted. And it is not going to update the index. Index will be as it is. It is not going to update that. But if I want to update the index, I'll tell you how to do that after some time. Okay, because I know you will ask this question, so that's why I told you right now. Wait, I'll tell you how to update the index. Okay, so this is how you drop the row. Similarly, if you want to drop the column, now which column should I go for? Let's say I want to drop this login time. Okay, I want to drop which one should I go for? Okay, let's go for only one. Why not? Why for two? So for dropping the column, same thing we have to use. Only one thing I have to change here. And what is that thing I have to change here? Axis. That means here I will pass the name of the column, not the index. So let's say I will pass here last login. If you want multiple columns to be deleted, just give comma and give the name of that column. Okay, but I'm taking only one column here, and axis should be 1. So I'll write here 1. Okay, now if you do this, you can see that that last login time column is gone. It's deleted. So this is how we drop any row or drop any column from the data frame that we don't require. Okay, now coming to this point, let's say we have deleted some row, right? So that data new 0 1 2 okay, we have modified this now. Okay, wait. Let me check it here again. Okay, now if you see here, 1 and 4 is gone. That was the index label, not index. That was the index label, the label that you can see here. Okay, now when you are dropping the row, you can see the index is not changing here. We got 1, so 1 is missing here. We deleted 4, that 4 is missing here. Now if I want to update this index, so for that I have to reset the index. That means I will write here data underscore new is equal to data underscore new dot reset underscore index. Reset index means you are resetting this value to 0 1 2 3 like this again. Now when you do this, let's see what we are getting. Okay, look here now. Now our index is 0 1 2 3 4. It has reset the index, but the previous index, which was earlier, it is added as a new column. It is added as a new column, which you can delete later on if you don't want this. You can delete this later on if you don't want this. So this is how we reset the index and we update the index to the original index 012, something like that. Okay, that's how we work with the index updation. Okay, so I hope clear everyone. These things are clear. Yeah, tell me. And everyone watching this session, please click on the like button. Hit the like button, everyone. Make it 100 now. Okay, now coming to the next thing. How to filter data. How to filter data. Let's say I want some data according to some condition or anything I want. How can you get that? So you only tell me what should I filter here. Tell me. What should I filter here? Sana, please go through the video again. You can scroll back, you can move back, and you can go through the video again. Okay, you will get to understand that. Okay, you can just move it back. Okay, because it does not delete the previous index. You can delete that later on. Okay, it does not delete that. It keeps that previous index for the reference. Maybe the previous index maybe is of our use. That's why. Okay, so let's say what I want to filter. Okay, gender. Okay, gender. Let's say I want only the male employee. Let's say I want only the male employee, or I want only the female employee. So how to do that? Filter team finance. Okay, we can do that also. So we'll do that. So how to do that thing? So for that, I'll let's say I'll define a variable here, filter. So filter is equal to, now what I want is I'll write here data of gender. I want to check for gender. So I'll write a data of gender equal to male. I want to check for male, so I will write here male. Now I have defined the filter here that data gender equal to male. Now I can write here, if I want to see all the rows where this filter is there, so I can simply write here data of filter. That's all. Data of filter. Now run this and check this. See, we are getting only the male data. See, we have total 424 male and 600 something we have, 500 something we have female. That's very simple. In the same way, let's say you want the members of the finance team. So I can write here finance. Okay. And here I'll pass team. Let's see. You can see here, I'm getting only the rows which is having a finance. See, I'm getting 102 rows. So there are total 102 people who are working in finance. This is how we filter the data. Let's say you want a person whose salary is more than 1,30,000. Let's say I can write here salary greater than equal to, let's say 1,30,000. Let's say. Now let's run this and let's see. Okay, so we have total 156 employees whose salary is greater than 1,30,000. See, so it's perfectly working. Okay, let's say you want the employee whose joining date is in who joined after 2014. Let's say who joined after 2014. That means in the year 2014. So how to do that? So I can write here joining date. Now look here. What is the date format that we have? Like this, right? So you have to write like this. Okay. And now I want 2014. So I can write here 2014. 0 1 0 1. So greater than or equal to, that means I want all the employees who joined after this year. So if I run this, oh sorry, I've done the spelling mistake. Look at here, we got all the employees who joined after 2014. Let me give it here 2021. Let's say 2021. I'll get less number of employee now. Right now we have 65. So no one. Oh sorry, I think I've given the wrong filter. No? I checked for the time, I think. Oh sorry, you have to check here now. Yeah, 15. See. Okay. So like this, we can filter the data. Now, maybe some of you thinking, how can we do more than one filter? Is there anybody who is having this question? Let's say I want a female employee from the business development team. I want to apply two filters. So for that, it's very simple. Right here, filter 1, gender, female. So one filter we have done. Okay. Date was 2 type format. No, there is no missing row, any data in the date. So here I will write what was the other filter which we want? Team. The team should be business development. Yes, we have to use bitwise operator, correct. So filter 1 and filter 2. Now I'll write here filter 1 and filter 2. I hope you know the meaning of and here. And means I want to apply both condition. Greater than, sorry, equal to. Okay, look here now. We got only female from business development. So we have only 61 employees. No, you can store that also. You can store this in a variable. Let's say I can write here filter underscore data is equal to this. Now if I run this, your data will be stored. You can print this now. Not only for view, you can store that also. I have stored that now. I have created a subset of the data frame. Okay. So this is how you apply multiple filter. Now tell me one thing. If I want that any of the two should be true, any of the two, what should I do? Either female or business development. Then what should I do in that case? Either female or business development. Yes, we have to use the OR symbol. And the OR symbol is this. This is the OR symbol. I hope you know this, right? So it will give you the either female or business development. See, here we have female finance. So it's female here. That's why it is true. So we got total 616 rows. Okay. So this is how we filter the data. We get the data that we want. And one of you asked me yesterday, no, we have only one format because I think you joined late today. Have you joined late today? I think you have joined late today. That's why you are asking this question. Because already we have converted the date time into one format. Already we have done that. Okay. Here we have done that thing. Okay. It is now same type only. Everywhere you will get a one type only. Okay. Okay. That's how we do the filtering of data. Now, one of you asked me yesterday, how can I get the row having only null value? See, right now we don't have any null value. But in case if you want that, I'll tell you now. Let's say you want all the rows where gender is null. So you can write here equal to np.nan. That will give you all the rows where the gender is null. But we don't have right now. But in case if you want to do that in future, you can use this. Right now we don't have any null value. That's why it is not giving you any record. But if you want to check for the null value, you want that rows only where the value is null, you can write here equal to np.nan. So it will give you all the rows where gender is null. Okay. So that's how we do this. And if you want to apply to the complete data, you can write here also data equal to np.nan. This is for the complete data. Okay. No. This is not working. No. We have to do column by column only. Leave this. Okay. Fine. Okay. So these are some, each NA and each null, they are same. Basically in R programming, we have each NA. Okay. But in Python, each NA and each null, they both are same. In R programming, we use NA. In Python, we use each null. That's the difference only. Okay. They are same only. Okay. Now coming to the next thing. Now whatever manipulation we have to do, I've explained that thing now. It's completed. Now the very most important thing that I'm going to discuss is whatever now I'm going to discuss, it is basically called feature engineering. Whatever we are going to discuss now, it is a part of feature engineering, where I'm going to discuss two things. The first thing that I will discuss is feature scaling, and second one I'll discuss is feature encoding. And one more thing I'll discuss that can also be a part of feature engineering only. Outliers. Handling outliers. Have you heard of outliers? I hope you have heard of outliers. Vibhuti, you have to run the code from the beginning. I think you have not run the code from the beginning. Please run the code from the beginning. You will get the output. Okay, so these are the things that I'm going to discuss in feature engineering. So one by one, I'll discuss this. Okay. So first of all, let me tell you about the feature scaling, or let me do it for encoding or scaling. Anything we can take first. Okay. So now for this one, I will use a notebook or a white book. Okay. I'll write and explain this. Yeah, outliers are unwanted data. We'll discuss that later on. Okay, so let me explain that now here. All of you, please pay attention here. Let me explain the different types of feature encoding technique and all these things we are going to discuss now. And then let me change the background color to black. Okay. I hope you can see my screen, everyone. The whiteboard screen, the blackboard screen you can see. Please confirm this. Okay, fine. So first of all, I'm going to discuss about feature encoding. Now, in this feature encoding, we have so many types of feature encoding. First of all, we have two types of data. One is I'm talking about only categorical data. I hope you know categorical data. Do you know about categorical data? That is having some category. Like in the previous data set, we have team column, right? Team column. We have gender column. We have senior management column. So these are the categorical data where you have some categories. So we have two types of data. One is categorical data. One is called, let me write first, ordinal data. One is your ordinal data and another one is your nominal data. Ordinal and nominal. Okay. Now, what is ordinal data? What is nominal data? Ordinal data is simply the data which is having some rank, or I can say which is having some order. Like, as for example, education. Okay, education. Like, if you go for the education, we have BTech, we have MTech, we have PhD. So PhD is more important. PhD is more higher. MTech is less higher than PhD. Then BTech is less higher than MTech, right? So we have rank there, right? We have a rank. Or you can go to the employees, manager. Then we have a director, like this, manager, director, management people, like this, or business development manager, senior manager, like this, right? So that is basically called an ordered data where you have some rank, that is called ordered data, or we can say ordinal data. And nominal data means no rank. Yeah, grade also, correct, grade also, no rank. Now what is the example of ordinal data? Gender is an ordinal data and a nominal data. Gender is a nominal data where we don't have any rank, right? So tell me, we have three columns here: team, gender, senior management. So what is team here? Team. What can you consider as a team? Ordinal or nominal? Ordinal, yes, because in the team we have the rank, right? We have the rank. Okay, we have a rank. Then gender is your nominal. In gender we don't have any rank. Male and female, they are equal. Okay. And in senior management, what is senior management? Senior management is true or false. So true is considered as, let's say, he belongs to senior management. So this is also a ordinal only. If any person is belonging to a senior management, he will have higher post, right? I can call it as a ordinal data also. So like this, we have two types of categorical data: ordinal or nominal. Okay. Now, based on the data set, we have encoding. Okay. We have the encoding. So first of all, for the nominal encoding, what are the different types? We have so many types, but I will just consider only one because that we use mostly, which is your one hot encoding. One hot encoding. So one hot encoding is a type of encoding which you use for the nominal data. I'll explain that. What is one hot encoding? I'll explain that. Okay. But right now, just remember the name. That one hot encoding is a type of encoding which we use for the nominal data. Now, for the ordinal data, the encoding that we use is, we can call it as a label encoding. Label encoding. Okay. So just remember these two names: one hot encoding and label encoding. These are the two mostly used encoding techniques. I'm going to discuss only these two. We have other also: one hot encoding with many variable, mean encoding, target guided ordinal encoding. But we don't have that much of time that I can discuss all, but I'll discuss the most important one that we generally use. So that is one hot encoding, and the other one is label encoding. Now I'll explain these two in detail here. So first of all, we'll discuss about the one hot encoding. One hot encoding. Now, please pay attention here. Understand what is one hot encoding. In one hot encoding, we have a concept of dummy variable. We have a concept of dummy variables. Okay, dummy variables we are having here. Now, as we all know that one hot encoding is applied for nominal data where we don't have any ranking. So let's say we have a data of country. Okay, we have a column country. Let's say India, USA. Okay, let's say Australia. Let's say I'm having these three. Let's say, okay, I'm talking about only three. Okay, now let me take China here. It is not okay. Let's say I'm having these three countries. Okay, so now let's say I'll take a column here value. I'm having a data here India, USA, China, India, let's say China. Now, first of all, what is encoding? Encoding means converting what? Converting categorical string value to what? To numerical value. Why we require this? Because we cannot apply any mathematical operation on the string data. In machine learning, we apply so many mathematical operations, mathematical formulas, and that formulas we cannot apply on a string data. We need a numerical data. And that's why we do encoding. So let's say this is my data and I want to convert this into numerical data. So if I am going for the one hot encoding, if you are going for the one hot encoding, what one hot encoding will do? It will create dummy variables. Now, what are dummy variables? Dummy variables are simply the name of the class only. How many class we are having here? Tell me. How many categories we are having here? How many class? How many categories we are having here? Tell me. In this country example, 3 category: India, USA, and China. 3. That means it will create 3 columns. It will create 3 dummy variables. That means it will create 3 columns like this. Like this, 3 column will be created. So if there are 5 class, 5 columns will be created. 10 class, 10 columns will be created. So there is a drawback of this, that if there are so many class, so many columns will be created. Our data set will have so many features. Okay. So in this case, multiple number of columns will be created. So in that case, right now the 3 columns are created. Now this is India, so it will be 1, other 2 will be 0. This is USA, so this will be 0, USA will be 1, China will be 0. China 0, 0, 1, India 1, 0, 0, China 0, 0, 1, and again China, so 0, 0, 1. So first of all, these things will be done. Okay. Now tell me, out of these three column, let's say, if I delete either India or China, anyone, then in that case, can we identify the country name by just two column, instead of three columns? Tell me, can we do that? Yes, we can do that, right? So let's say if I drop India, here both values are 0. So what I will consider that this is India data, right? Here this is 1, that means USA. Both are 0 means India. Both are not 0, that means it is not India, right? So in the one hot encoding, after creating these multiple columns, either the first column or the last column, any one of the column, any one of the column is dropped. Any one column you can take. You can take the middle one also. That's your choice. So we drop one column. So that I'll explain. First of all, let me explain the concept. Obviously, if I'm explaining the concept, I'll tell you how to do that. Okay. So in the practical, I explain everything, how to do this. Right now, I have explained the concept. So I hope one hot encoding is clear to everyone. Please confirm this. Is it clear? Okay. Now, it can be done by two ways. It can be done by two ways. The first way is using pandas. In the pandas, we have one function which is get underscore dummies. And second way, it can be used done by the sklearn library, scikit-learn library. In the scikit-learn library, we have a function which is one hot encoding. I'll tell you both way in the practical. In the practical, I'll tell you both way. Get dummies also and one hot encoding also. Okay. So it can be done by two ways. Using pandas also, using sklearn also, scikit-learn also. Just this was all about the one hot encoding. Now coming to the next one, which is your label encoding. Okay, label encoding is very simple. Now, as we all know that label encoding is applied to a ordered data where we have some ordering, where we have some ranking. Let's say you have a data, let's say education only. We have BTech, we have MTech, and we have PhD. Let's say. Now, in this case, based on the rank, you assign the label. Now, tell me, what will be the rank of this data? The degree having the most priority is rank 1. So tell me which one you will assign as rank 1. Tell me. Rank 1 will be PhD, right? Rank 2 will be MTech and rank 3 will be BTech. Let's say. Okay. PhD, MTech and BTech. So now based on the rank, you assign the label. So this is called label only. Sorry, this is the rank. Now the label would be the class having the highest rank. The class having the highest rank will be assigned a higher value. That means this one you will assign as label 1, You can assign it as label 0 also. That's your call. Okay. This one you can assign as label 1, and this one you can assign as label 2. That means the class having the highest rank will be assigned as a higher value. That means in that case, this is the higher value. So model will give this high priority. This feature as a high priority. Okay. So this we do in the label encoding. Based on the rank, we assign the labels. That's all. That's all. So I hope the encoding is clear to everyone. Please confirm this. Is this encoding clear? Give me a thumbs up on the chat. And everyone watching this session, like, click the like button, hit the like button, all of you. Hit the like button. Girish, I just explained. When you have a rank data, go for label encoding. When you don't have a rank data, go for one hot encoding. That's a scenario. I just explained few minutes back, na? When you have a rank data, go for label encoding. When you have a normal data where we don't have any rank, go for the one hot encoding. Okay. Now, the next thing. See, today I'll explain the complete theory regarding this label encoding, label feature scaling, and outlier. Okay, I explain everything today, whatever I want to discuss. The next one that I'm going to discuss is your feature scaling. Feature scaling. Now, what do you mean by feature scaling? What do you mean by feature scaling? Feature scaling means converting the value to some specified range, to some range. That means, let's say you have a data age, salary, let's say age, salary, experience. Let's say I'm having this data. Okay. Now age is, let's say 25, let's say 28, let's say 30. Okay. Now salary is, let's say 1.5. Okay. Let's say 2.5 lakh, let's say 3.5 lakh. It's per annum. Okay. Don't call it as monthly. You can take anything. And experience is, let's say 1 year, let's say 2 year, and let's say 3 years. Okay. This is the data that I'm having right now. Or let me make it more simple. Instead of lakh, I'll take here, let's say 15,000, 25,000, and let's say 40,000. Let's say this is the data that I'm having right now. What is the range of age here? What is the range of age? It is 25 to 30. What is the range here? 15,000 to 40,000. And what is the range here? 1 to 4. Now, when you have a feature like this, where you have a different range of the feature, then in that case, model, when you apply this to the machine learning, model will give the highest priority to the higher range feature. That means it will give the highest priority to the salary, then it will give to the age, and then it will give to the experience. Like this. Let's say. Okay. So basically this should not happen. Model should not give the priority like this. So when we have the data like this, you may not get the better accuracy. So in that case, what do? We scale the data. This is also known as normalization. Normalization. We normalize the data so that they come in the same type of range. What is the same type of range that I'll discuss after some time? Okay. So we scale the data so that they all looks almost same. Okay. They have some similar kind of range. They are normal. They all look normal. Okay. And that is called scaling. So we have basically two types of scaling. We have two types of scaling. One is your standard scaling, and another one is your min max scaler. Standard scaler and min max scaler. Let me name this as scaler. Okay. Standard scaler and min max scaler. Now, what is this standard scaler? What is this min max scaler? Now I will tell you that. Okay. Standard scaler is something which we apply to any type of feature, like wherever we want this. And basically min max scaler, we generally apply this to the neural network part, or I can say where we are working with images. Okay, when we are working with the images, we have the range of the pixel value 0 to 255. So in that kind of data, generally we prefer for the min max scaler, and in other data we prefer for the standard scaler. So in 90% of the cases we go for the standard scaler. Now what this standard scaler does, it, after scaling all the features, it makes sure that the mean of the feature is 0 and the standard deviation is 1, near to 1. Okay, that means the mean of age will be 0, the mean of this one salary will be 0, the mean of experience will be 0, and standard deviation also will be 1. Not exactly 0, not exactly 1, somewhat near to 0 and 1. So that they all will be of normal range. They all will be of normal range. So what is the formula for doing the standard scaling? Anybody know the formula of this? Anybody? I hope so. No. Okay, fine. I'll tell you. The formula is z is equal to okay, x is my sample which I want to convert. So x minus x of mean divide by standard deviation. This is the formula. Okay, that's the formula. This is the formula that we use in the standard scaling. And we have a library, so we don't have to remember this formula. We have a library which will do that thing, but this is the formula. And in the min-max scaler, we actually convert the data either between 0 to 1, -1 to -1 or -2 to 2. Any range you can take here. There is no fix here. You can define any range that you want to take. Any range. Okay, any range you can take here. 0 to 1, -1 to 1, -2 to 2, 8, -8 to +8, anything we can take here. And the formula for the min-max scaling is, let's say x scaled is equal to, z is simply, we call this as z score. Okay, z score. Okay, z score. So x scaled will be x minus x of minimum divided by x max minus x mean. X minus x of minimum divided by x of max minus x of mean. This is the formula for the min max scalar. Okay, that's the formula. So these are the two types of scaling. We have one more scaling, which is basically called robust scalar. Robust scalar, which we apply to the data set where the feature is having some outlier. So feature having outliers. We apply the scaling to that data where the feature is having some outlier. What is outlier, which I'll discuss after some time. Okay, so the formula for this robust scalar is x of scaled is equal to x minus x of median divide by IQR. Now here IQR is the interquartile range, which I'll just explain after some time in the outlier part. Interquartile range. I'll explain this after some time in the outlier. What is IQR? You'll get to know after some time. Okay, so these are the different types of scaling that we have. How to apply this, we'll see in the practical. Okay, so tell me everyone, is this scaling clear to all of you? Scaling is clear? Yeah, all of you tell me. Is this thing clear? Okay. Standard scalar means you are converting the data to a standard range, normalization range, where after converting the mean will be 0, standard deviation will be 1. Here we convert the data between -1 to 1, 0 to 1, -2 to 2. Okay. If you have still some doubt, the doubt will be cleared in the practical. Okay. So when I'll do the practical, your doubt will be cleared. Don't worry. Okay. Now the last thing in this one I'll explain is your outliers. Now, what are outliers? Outliers, I can say that irrelevant data. Or I can say that boundary values. Boundary values, okay? So, or I can say the data which is distant, from all other observations, which is totally different. Okay, textbook, can you suggest a Vatsal textbook? I will share one PDF file in the WhatsApp group. You can go through that PDF file. There is one book or a PDF of one book. You can go for that. Okay, but this notes I will provide you on the WhatsApp group also. You can take these notes also. Okay, this image I'll explain that in the form of image. I give that in the form of image. Okay, now, yeah, what I was saying, yeah, so which is distinct from all the other observations. Now, what's the meaning of this? The meaning is, let's say, okay, let's say you have these samples here. These are my data points. Okay, now let's say you have some sample which is present here, one or two samples like this. So these two sample will be known as what? Outlier. This is your outlier. Like as for example, let's say you have a age data. We have 12, 16, 18, 14, 12, 15, 18, 20, 22, 18, 20, 17, 90, 80, 21, 23. Now tell me which is the outlier in this data. What is the outlier? What is the outlier in this data? Which is irrelevant here. Yes, 80 and 90. These are my outliers. So I hope you understood this outlier. So outlier creates sometimes problem in our data set. When you are creating a model, it may give you the wrong prediction, or it may give you the bad accuracy. So sometimes it affects the model. In that case, you have to treat this outlier. Either you delete this or you replace this with some other value. Like it's like a missing values. Either you remove it if you have so many outliers, go for replacing. If you have some 2-3 outliers, go for uh, um, removing it. Okay, but generally we don't have so many outliers. So many outliers doesn't mean that it is an outlier. If we have so many data points on this here, can we call that this is outlier? If we have so many data points related to 90, 80, that is not outlier, right? If we have only little some samples only, then that is only called outliers. Okay. Now, what is the way that we use to treat the outlier? Now, let's understand that. Ways to find out outliers. What are the ways to find out the outliers? That you will get, your questions will be answered in the practical. You'll get to know that in the practical. Okay. And right now also you'll get your answer. I'll tell you in this way only. Now, what are the different way to find out the outlier? The first way is that you plot a which graph? Scatter plot. We plot the data in the form of scatter plot. So through scatter plot, we can identify the outliers. The second way is using box plot. Box plot I'll explain in detail. Okay. The third one is using Z-score. Z-score formula I have already explained that some time back. I'll explain that again. Okay. Z-score. And the fourth one is using IQR, which stands for interquartile range. Interquartile range. Okay. So these are the four ways through which you find out the outlier. In the practical, I'll demonstrate all of these. Don't worry. I'll demonstrate everything. Okay. Now, scatter plot, you all know, like this is the example of a scatter plot that I have taken here. This is scatter plot only, na? Okay. Let's come to the box plot. Box plot also I'll explain in the practical only, because this is kind of a graph. So I'll explain in the box plot, but I'll tell you something here. Let in a box plot, you get something graph like this. You get a graph like this. Okay, where you will have total 5 lines. 1, 2, 3, 4, 5. So this is your minimum value. This is your maximum value. This is your mean value of the data. mean. Okay. Wait, I think I missed one line. 1, 2, 3. That is fine. Okay. This is your 25 percentile and this is your 75 percentile. Now, first of all, tell me, do you know about percentile? I hope you know about percentile, everyone. Tell me. Don't call this as a median. Call this as a median. Call this as a median. Rank. We call that as rank. Okay, see, I'll tell you. See, basically in this graph, this is basically called the IQR. This is only your IQR, interquartile range. Okay. So this 25 percentile is called lower quantile. Lower quantile. Okay. And 75 percentile is called higher quantile. Higher quantile. So higher quantile minus low quantile is your IQR range basically. Okay. So now, what is this percentile? First of all, let me tell you that because I think you are not having that. It's a very simple thing we have seen in the different entrance examinations. Like, let's say you have 100 students. We have total 100 students. Okay. I am having, let's say, I scored out of this 100 student. I am also a part of that 100 student. Okay. I scored, let's say, 20 marks. I scored 20 marks out of anything. Okay. Out of that 20 marks. Now, my percentile is 90%. Now, what is the meaning of this? If I'm saying that I scored 20 marks and my percentile is 90%. So tell me the meaning of this 90 percentile. Anyone? Those who know this. If I'm saying that my marks is 20 and my percentile is 90%. 1 not 10. Yes, 90% of the student. That means out of 100 students, 90 students have scored less than 20. 90 students have scored less than 20. Yes, I am among top 10%. Correct. That's the meaning of percentile. Okay. So I hope you understand the meaning of percentile. So this is 25 percentile. This is 75 percentile. Okay. So let's discuss this now. What is this? How you treat this box plot to identify the outlier. Now here, this minimum and maximum value is not the minimum and maximum from the data set. See, let's say you have a data set 10, 15, 18, 20, 16, 21, 24, 15, 16, let's say 80, let's say 100, let's say 80 and 100. Now, from this complete data set, what are the outliers? These are the outliers, correct? These are the outliers. Or let's say I'm having some value here also. Let's say minus 20, minus 80, let's say. Minus 20 and minus 80, let's say. Okay. So these four, I can consider it as an outlier. These four. Let's say minus 70. Don't take 80. 20 will be not be 70. Minus 70 or minus 80. So here, what is the minimum value? What is the minimum value in this? What do you say about this minimum value? Is it minus 70? Those who know, then tell me. What can be this minimum value? This minimum value is not minus 80. It's not minus 80. It is minimum value of a relevant data. So what is the relevant data here? This can be called our relevant data. Am I right? So minimum value will be 10. See, exactly it will not be 10. It may be some decimal also, 9 point something like that. But I'm explaining this for just for understanding. So your minimum value will be 10. And what is the maximum value? Maximum value will be 100 or something else. What will be the maximum value? It will be 24. 24. Correct. That's your minimum, that's your maximum. So the data point in the graph, see, you'll get this in the form of a graph. Whatever points you will be getting, after this line or before this line, they will be treated as an outlier. So in the box plot, whatever data points you are getting after this line or before this line, then they will be treated as an outlier. So I hope you understood how we can use box plot to identify outlier. Please tell me if you're still having some confusion, it will be cleared in the practical. Okay, it will be cleared in the practical. Fine. Fine. Now coming to the next thing, how we can use Z-score to identify the outlier. Z-score. Now, I just explained the formula of Z-score a few minutes back. What is the formula of Z-score? Tell me. Tell me. It's basically x minus x of mean divided by standard deviation. This is the formula, right? So what we do in this Z-score, basically, let's say if this is my distribution of the data. Let's say this is my data distribution of the data. Okay. So what is this point called in the distribution of the data? Tell me in the histogram, what is this point called? Do you know this? This point? This is basically Z. Here Z is 0. And this we call, no, in this one, in the this one, mean. Yeah, mean. Okay. Now what is this called here? 1, 2, 3. Let's say 1, 2, 3. So this is Z equal to 1, this is Z equal to 2, this is Z equal to 3. This is Z equal to 1, this is minus 1, this is Z equal to minus 2, this is Z equal to minus 3. So this is your first standard deviation, this is your second standard deviation, this is your third standard deviation. Similarly here, first standard deviation, second, third standard deviation, and in the third standard deviation. So basically, whatever data points you are having in between this one, it will be not considered as an outlier. But if you have some data point either this side or this side, then they will be treated as an outliers. That means the data point where the Z-score is greater than 3, then what you will consider this? Greater than 3. If you are getting the Z-score of a data point greater than 3, then that will be known as outlier. This is how we treat using Z score. We calculate the Z score for the data points, and if the Z score is greater than 3, then we treat that as an outlier. That's simple. Simple. Okay. Now coming to the last step, which is your interquartile range. Using interquartile range, IQR. Okay. How to find out the outlier using this IQR? Using this IQR. Now in this one, what we do, we basically use 75 percentile of the data set and 25 percentile. These two things are used in this. Just remember this. These two things are used. Okay. So here, first of all, we arrange the data in ascending order. First of all, we arrange the data in ascending order. After arranging the data in the ascending order, we calculate Q1. Q1 means, what is the meaning of Q1? First quantile. And what is first quantile? 25%. Q1 and Q3. Q3, which is your quantile 3, which is 75 percentile. So we calculate Q1 and Q3. Okay. Q1 and Q3. Then we calculate IQR. And what is IQR? IQR will be Q3 minus Q1. Q3 minus Q1. Then after this, we calculate the lower bound. Lower bound value. Lower bound value means basically this value, you can say. This value, okay? Here basically this kind of thing we use here. So lower bound value means the value which is the lowest one. We can say the lowest value which is not an outlier. So for the lower bound, what we do here, we multiply, Q1 minus 1.5 multiplied with IQR. Q1 minus 1.5 multiplied with IQR. Now why 1.5? This is just by the experience. So many tests has been done. After being so many tests, it has been assumed that if you are taking a value of 1.5, you will get a better result, and that's why we take 1.5. Okay. And the upper bound will be Q3 plus 1.5 multiplied with IQR. That's a lower bound and upper bound that we have to calculate. Okay. Okay. So whatever data point is less than lower bound, that means before the lower bound, or whatever data point is greater than upper bound, that will be treated as an outlier. That's all. Let's say you got the lower bound value as, let's say 10, and upper bound you got as, let's say 30. So the values greater than 30 will be outlier, and the value less than 10 will also be the outlier. That's all. So this is how we treat outlier. There are 4 different ways. In all the 4 ways, I'll explain in the practical in the next class. So how to do feature scaling, how to do feature encoding, how to do this outlier, everything I will be implementing this on a data set, and we'll apply this and we'll understand this, how to apply this to your data. Okay. So I hope you all understood this, everyone. Tell me. Yeah. So these are the things that I have to discuss for today's session. And if you want this notes, this file, I can share with you on the WhatsApp. I will share that with you. You can keep this for your reference. Okay. What is the date today? 25th. No? Let's say feature engineering. Okay. Okay. So I've saved that and I'll save that on the WhatsApp. Yeah, collab file also. Collab file also, I'll do that. Don't worry. Let me check. Okay. So there are 4 different images. I'll share all these 4 images in the WhatsApp. As a document, I will share so that the quality don't get reduced. Okay. I'll share this as a document. Okay. So you can download it from there. Okay. So you can keep this for your reference. Fine. So I hope you enjoyed today's session. Here, Vibhuti, there is no option to share the image here on YouTube. So I cannot do it here. You can take it from the group. Okay. So I hope you enjoyed, everyone, today's session. Yeah, next class will be on Monday at the same time. Yes. There will be a 2 days holiday now. Dr. Vamsi, if you are not in the WhatsApp, please join the WhatsApp now. The WhatsApp link is in the description. You can join there. Okay. Yes. Next class will be on Monday. Now, if you have any questions, anything you have to ask, I'll tell you. No. There are 4 WhatsApp group. Just try all the groups. There will be some group which is empty, which is not full. Check that. Let me check. I'll tell you. Group number 3 is empty. Group number 3 is not full. Group number 1 is also not full. There is 1 space. Okay. You can try 3 or 4. 3 or 4 is not empty. Okay. And not full. Still 4 of March. What? I'm not getting your question, Varun. What is 4th of March? So you're talking about till. Yes, it will be till 4th of March. Correct. Till 4th of March. Please provide a small project on data science for practice. Yeah, I'll share the notebook. See, basically, if you want to practice this, we have used the Titanic data set in some practical. Just tell me, have we used any Titanic data set in some session? I think no, right? So I will share one Titanic data set, or you can read from here itself. I'll tell you how to read. Data is equal to sns dot get a load underscore data set. Okay, and here you can write Titanic, and then data dot head. Okay, you can use this data set for the practice. Just analyze this complete data set and tell me in the next class what problems you found in this data set. Okay, what cleaning process is required in this data set. This data set we are going to use in the logistic regression session. In that one we will use this. So just try to clean this data, find out the problem, analyze this, and tell me what problems you find out. So I have written the code in the same file. You can use this data set for analysis. There are some missing values also here. You have to apply label encoding also. Label encoding I haven't explained right now, so you can leave that. But missing values and all things you can do here. You can use this for the practice. Everyone do this, okay? Fine. Okay. So now any questions, any doubt? Okay, now I'm going to share the attendance link. So you can go and fill the form, and you can come back, and then you can ask your doubts if you have. And everyone present here, please click on the like button. Everyone, please hit the like button. It's still 90 only. Like is only 90. Make it 150 at least. Hit the like button, everyone. This is only small support I want from your side, and you are not doing that. See, it motivates me to bring more free sessions for you. Please do that. And subscribe to my channel if you have not done. I have not sent the image in the WhatsApp, Dr. Vamsi. I will share that after some time. You can take it from there after some time. Okay. After some time, I will send that. Okay. No. Deepak, basically, when we go for machine learning, we never include the image name column. Name will not help you in doing the machine learning prediction. So we don't consider name column. We simply drop it. Okay. We drop it. I have given the attendance link on the chat as a pinned message. Everyone go and fill the form, attendance form, and come back. And if you have any doubts, you can ask me after that. Okay. And hit the like button, those who have not subscribed to my channel yet. Now, if you have any questions, you can ask me. Yes. In the next week, we will cover the ML algorithm in the next week. All the classes will be related to ML algorithms and deployment and everything we'll be doing in the next week. Don't worry. And if I feel I can extend this to Saturday, Sunday also in the next week. So don't worry. I can do that also if I feel required. Okay. I will cover about regression problem statement. That means one algorithm related to regression. It will be linear regression, then KNN, then logistic regression. These three algorithms I will cover. And then I'll cover how to deploy your project, how to create a web application of your project. These are the things that I will discuss in the next week. Okay. And if you all are interested, I can arrange 1 or 1.5 hour session on Sunday also, this coming Sunday. So if you want, I can do that also. No, you can just write this code to get the Titanic data set, to read the Titanic data set. You can just write this code. Okay. No, you just have to take this code, Okay, how many of you want the session on this coming on this coming Sunday, day after tomorrow? Just give me a thumbs up. Those who want the session on Sunday. I'll continue this only. I'll tell you the practical of this feature engineering. But see, if you'll come only 10, 15 of you, then I will not do that. At least there should be 100 participants coming on that day. Tell me. Extend the timing. See, I can do that, but I think more than 1.5 hours will be little bit hectic for you. It will be more. So that's why I don't extend that. I can do that. I don't have any problem, but I think it will be more difficult for you to understand more things. Okay. Attendance link is already pinned on the chat. Hasina, you can take it from there. Okay. Okay, only 3, 4 I can see. Okay, fine. We'll have the class on Monday only then. Okay, have you all filled the attendance form? Everyone? Day 10 Python live class. Like, are you asking Alok that should I repeat the Python live class 10th day class? Just go through the recorded session, na? I cannot continue that thing because when I teach some topic, there is a flow of that topic. Okay, so directly I cannot start day 10. So you can just go through the recording. Na, it's a recorded session. You can take that. Okay. So we'll have the next class on Monday only. Okay, on Monday only. Yeah. You want all 10 days classes? See, it's there. Wait. Just go to my channel. Go to this playlist, and this is the complete playlist. Here you'll get all the videos. See here. Here's a list of all the 10 videos. Okay. You can refer this. I'll share this link. This is only you want, right? See the link I have given that on the chat. Okay. It contains all the 10 day sessions. Okay. Okay, so have you all filled the form? Can we wind up the session now? Book. I will share the PDF file of the book in the WhatsApp group. You can take it from there. Okay. You can refer that for your learning. Okay. Okay, then. So I hope you don't have any questions now. Fine. So thank you so much, everyone, for joining today. Please do hit the like button and subscribe to my channel if you have not done. In this coming 2 days, Saturday, Sunday, there will be a holiday. So do practice whatever things we have done in this complete week, because that will be very much helpful in the next class. In the next class, it will be very much helpful. So do practice whatever we have done in the last thing. Okay, in the last week, in this coming days. Okay, last days. Yeah, I'll share the collab link in the group. Anand, you can take it from there. Okay, after some time, I'll share that. Okay. So bye everyone. Take care. Stay safe and keep rocking. Yep. Bye. So I'll see you on Monday. Enjoy your weekend. Happy weekend. Bye.